Hello everyone, welcome to our next chapter on quadrilaterals. You'll notice here that it says chapter 6. That's what it is in our textbook if we used one, or if you have one that you've taken home as an extra resource. However, we call it chapter 4 just because we want to keep things in order in our Schoology and in our paperwork and stuff like that. So this section is going to deal with angles of polygons. So definition of a polygon review. Over on the left, we have some examples of polygons, and on the right, we have examples of shapes that are not polygons. So in our pictures over here, on the left side, the polygons, notice they're all straight segments, the sides, they join, and they don't intersect each other. So over here, the ones that are not polygons, this is the reason. The first one is not. Those two sides don't join. Over here, the reason is they are intersecting. The sides are intersecting, so it's not a simple polygon. And then over here, that side's not even a segment. It's something that's arched and round, so it is not a polygon. So do you remember the names of the polygons shown below? So I would like you to pause the video and write in next to the arrows. So for example, we've studied the first one quite a bit. It's a triangle, the purple one with 3 sides. See if you can name these and then compare it to my answer. So pause the video, fill it in, let me know what you get. Okay, so here are all the side names filled in. I do want you to notice that I matched the color that I wrote the shape name in to the color of the shape. Pentagon was kind of hard for me to find that color, but not too bad. All right, so we have a triangle has 3 sides, quadrilateral has 4, a pentagon has 5, a hexagon, 6 sides is a hexagon. My students taught me that. They're like, oh, my teacher in grade school taught us that if the letter 6 has an X, it's a hexagon. So I'm like, oh, I love it. 7 sides is a heptagon, 8 sides is an octagon, 9 sides is a nonagon, 10 sides is a decagon. So what if we have a shape that doesn't have those number of sides? So for example, if a shape has 11 sides, what do we call it? Well, a lot of times when they don't have specific names, you just put the number of sides they have, so 11 gon. But this one, I did look it up. We don't usually use this name, but it's a hendecagon. Hendecagon. Couldn't even pronounce it. A 12-sided is a dodecagon. That one's more common to use. So then n sides, like if I had 27 sides, it would be a 27gon. So we're just going to generically name that an n-gon. So I would say all the way up to from 3 sides to 12 sides, know the name of it. Besides an 11-sided one, hendecagon, I don't really see that often. So if you just call it an 11gon, that'll be fine. And anything above it, we're just going to call it a 17gon or whatever, however many sides it has. All right, so 7 sides, you should know it. 12 sides, you should know it. 21 sides, call it a 21gon. So on this page, we're going to find the sum of the interior angles of a convex polygon. I didn't talk about convex versus concave on the first page, but I should have. A convex means if you were to take any side of the shape and just extend their sides, these blue lines are never going to touch any point on the inside of it. Whereas if I drew a shape like this, if I was to extend these sides, right here I'm okay, but here, notice that I am hitting points that are inside of the polygon. So this one is considered what's called concave. It kind of caves in on itself is how I remember. It caves in. The ones where if you were to extend the sides, all the ones here that were already drawn before I got to this page, all of those are considered convex. Okay, so if I have a triangle, let's fill out this chart. It has 3 sides. The polygon name, as we know, is triangle, so I'm going to fill that in a second. But the number of triangles that I could form inside of it, there's only one. There's only one triangle that I could create in there. And we know, hopefully, at this point, that the interior angles, the sum of the interior angles of a triangle are 180 degrees. All right, so it's a triangle, 180 degrees. Now, if I take a 4-sided figure, like this green one here, if I draw in this yellow diagonal connects 2 vertices that are not next to each other, they're not adjacent. This triangle right here has 180 degrees, and this triangle right here adds up to 180 degrees. So that's called a quadrilateral. the number of triangles that can be formed are 2. And so if I was to take the 180 from this triangle plus the 180 from this triangle, that's going to add up to 360. Okay, 5-sided pentagon, like the government building. That's how I always remember, because it's in the shape of a pentagon. It has 5 sides. Let's see how many triangles we could form here. We have this one, and this one. So there's 3 triangles that can be formed. So the way that I would find the interior angle, I would do 3 times 180. I'm always multiplying here by 180 because that's how many triangles there are, and the sum of the angles of a pentagon are 540. Here I also multiplied by 180. Okay, and one thing I do want to also mention, I didn't have to draw them this way. Let's say I started at this vertex. I could have drawn here and here. That would still be 1, 2, 3 triangles. If I drew it from this vertex, I'd have 1, 2, 3 triangles. Now my picture kind of looks like a mess, but I could do that at any point, drawing the triangles, and see how many from any vertex would be formed. Okay, I would like you to fill this out for 6 and 7, and then we'll talk about the generic rule for n number of sides, meaning n could be any number of sides greater than 3, obviously. So pause the video and then fill this in and then unpause it, and we'll see what we all get. Okay, so hopefully if it has 6 sides, 7 sides, you filled in the correct name, the number of triangles, and the interior sum. So let's try to find a pattern. This is going to be called an n-gon. Notice how, let's see the relationship between the number of sides and the triangles formed. Here we had 3 and 1, 4 and 2, 5 and 3, 6 and 4, 7 and 5. So what are we doing to get the number of triangles formed with relation to the number of sides? It's always the number of sides, n, minus 2. There's always 2 less triangles than there are sides. So if I had a 100-sided figure, which would be very difficult to draw, it would be almost a circle, right? The more sides I draw, the more my shape starts to resemble a circle. But 100-sided, I would be able to draw 98 triangles. So what we're always doing is we are taking n minus 2 and then taking that number times 180. This is the same thing if I put it out in front, because I think a lot of times when we're multiplying, you have to do distributive property. Students prefer having that 180 out in front, but it's the same thing. So our new formula is the sum of the polygon with n number of sides is n minus 2 times 180. Okay, so first example here, find the sum of the angles, interior angles of a decagon. All right, so the first thing I need to figure out is how many sides in a decagon. It is 10. So the sum of the 10 interior angles is going to be 10 minus 2. I put 10 in place of n times 180. So this is equal to 8 times 180 degrees. And so I get a sum of 1,440 degrees. Second one says, find the measures of the angles of the quadrilateral. So here's my quadrilateral. All of its angles are in terms of x. So I need to find x. In order to find x, or anytime you're given a shape, the first thing you want to do is find the sum of the angles. Because we need to know what to add this up to. So if it was a triangle, we know that it adds up to 180. Maybe you know what the angles add up to in a quadrilateral, but it is 360. Or you could look up to our little charts and you can see that it's 360. So then the second thing I'm going to do is set up an equation and solve for x. So just like with triangles, we're just going to take each angle here and add it up to 360 in this case. So 5x plus 11x plus 4 plus another 5x plus another 11x plus 4 is equal to 360. You're going to encounter problems like this where you're going to be given a shape that's drawn, and sometimes the shape has 6 sides, and I don't know what it is. Students always know we're going to add up all the angles. They do that part correctly, but then they equal it to 360. only quadrilaterals add up to 360. If you have a 6-sided shape, you don't add them up to 360, you add them up to 720. If it has 7 sides, the equation is going to equal 900. So just be careful of that. I don't know what it is about adding them up to 360 that students make that mistake quite often. Okay, so let's combine like terms here. We have 5x plus 11x plus 5x plus 11x is going to give me 32x plus, and now I'm going to add up the constants. So 4 plus 4 is just plus 8, and that's going to equal 360 because this is a quadrilateral. Let's subtract 8 from both sides. I'm going to end up with 32x equals 352. Divide both sides by 32. X is going to equal 11. Okay, that is not what the question wanted me to find. They told me to find the measures of the angles. I didn't waste your time. It's just that I needed to find x. So here, I know that the measure of angle R is going to equal the measure of angle T. And what's that going to be? 5 times 11. So this is 55 degrees, and so would angle T would also be 55 degrees. All right, now let's do the same thing for angle S and angle U. It would be 11 times 11 plus 4. So I get 121 plus 4, that gives me 125 degrees. And I, of course, should, as always, go back and plug this in and see that that makes sense. Just on my calculator, do 55 plus 125 plus 55 plus 125. Does that equal 360? If it does, I could be confident that my answer is correct. On this page, we're going to determine how to find the sum of the exterior angles. Exterior angles are ones that are, if you were to extend the sides of a shape and kind of throw it, it's kind of like a throwing star, really. That's how I think of these problems. But here, we have a triangle, and we extended each side. Let's find the sum of the interior angles. Well, triangle we're very familiar with. It's A plus B plus C equals 180. If I call these angles A, B, and C, I want to rewrite the exterior angles in terms of A, B, and C. If this angle here is A, this one has to be 180 minus A degrees. If this one here is C, this one has to be 180 minus C degrees. And finally, this one would be 180 minus B degrees. Whoops, not a squared, degrees. So let's add them all up and see what we would get. 180 minus A plus 180 minus B plus 180 minus C. If I add up the constants, meaning 180s, 180 plus 180 plus 180, that's going to equal 540. So I have 540 minus A minus B minus C. Now what I'm going to do is I want to separate the A, B, and C, and I want it to look like what I got up here. So what that means I'm going to do, I'm going to factor out a -1. When I factor out a -1, I get A plus B plus C inside the parentheses, because if I was to distribute that -1, I would have this. So we already know that A plus B plus C from up here, right? From up here, we know that what it equals. It equals 180. So this whole thing is going to be 540 minus 1 times 180, really. And so we get 360. Interesting. So the sum of the exterior angles in a triangle is 360 degrees. Let's do this for a quadrilateral. So I'm going to go ahead and label these angles. I'm going to pause the video and label them the way I did previously, meaning I'm going to take this one, write 180 minus A, and please do the same. All right. First thing, find the sum of the interior angles. A plus B plus C plus D equals 360 because this is a quadrilateral. So the sum of the exterior angles, 180 minus A plus 180 minus B plus 180 minus C plus 180 minus D. Let's clean this up. Again, adding up all my constants, 180 plus 180 plus 180 plus 180 is 720, and then I'm left with minus A, minus B, minus C, minus D. We're going to do exactly what we did up top. We want to be left with A plus C plus D, because I know what A plus B plus C plus D, I know what that equals, so I want to rewrite this equation so it's in terms of that. So it's going to be 720 minus 1, and then look what happens, A plus B plus C plus D, which we know is 700, or just kidding, 360. So 720 minus 360 is 360 degrees. For a pentagon, we're going to do the same thing. I'm going to write it out. You don't have to necessarily. I'm going to write it out. I'm going to pause the video, write it, and show it and talk you through it. So give me a moment. Okay, so hopefully you see a pattern that's forming here. The sum of the interior angles is 540. I named all the interior angles in terms of their adjacent, or exterior angles in terms of their adjacent interior angles, and then wrote the equation. I knew that I'm going to have to isolate the A plus B plus C plus D plus E, which I know that value is 540, so I substitute in 540, and it's 360. So what do you notice about the sum of all of these? Triangle, 360. Quadrilateral, 360. Pentagon, 360. What is always going to be the case? These angles always add up to 360 degrees. Always, 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 always. I always think, and I'm going to tell you this in class, like if I was to throw this, like through the air, I always think of this as like a, one of those throwing stars. If I was to throw it, it's going to rotate 360 degrees through the air towards my target. Okay, so some of the exterior angles, regardless of what the shape is, how many sides it has, is always 360. Okay, so one definition here that we have is a regular polygon. A regular polygon is not like, it's just like kind of normal and like basic, like you'd always see it around. No, it's not just like a regular house or a regular car. It actually means that it's a polygon that's equilateral and equiangular. So all of its sides are the same, all of its angles are the same measure, okay? It doesn't just mean like, just some run-of-the-mill, whatever type of polygon that you'd spot in any American town. No, it has a specific meaning. Okay, so let's take a look at some practice problems here where we're going to use a combination of the things we've learned. Interior angle sum, exterior angle sum, the fact that it's regular. So over here, we are finding the measure of an exterior angle of a regular hexagon. When you want to find individual angles, whether they be interior or exterior, you can only do that if it's a regular shape. Think about a triangle. If I wanted to find each interior angle of a regular triangle, that's an equilateral, equiangular, they're each going to be 60 degrees. How would I get that? I would take the sum of the angles, 180, divide by the number of angles that there are, aka the number of sides in the shape. I would divide by 3, I get 60. I can only do that because I know that it's an equiangular triangle. If I just gave you any triangle and said find each angle, if I don't know any of them, I couldn't do it. It's impossible. So this only works for regular shapes. Okay, next thing we need to remember is when I put n in these formulas, n is equal to the number of sides. Now, however many sides a polygon has, that's also how many angles it has, right? It should make sense. That's how many vertices it has. A triangle has 3 sides, 3 angles. A quadrilateral, 4 sides, 4 angles. A pentagon, 5 sides, 5 angles, and so on. So here we're going to be finding the measure of an, so like each exterior angle. So what we're going to do, whether it's interior or exterior, we got to find the sum. Now here, because it's exterior angle, we're going to find the sum of the exterior angles and divide it by n, the number of sides. So because it's exterior, regardless of how many sides it has, we just went through this, they always add up to 360. The exterior angles always add up to 360 degrees. I would divide this by 6, and I get my answer, which is 60 degrees. Each exterior angle in a regular hexagon is 60 degrees. So that wasn't too bad, hopefully. Now, if we want to find the measure of an interior angle of a regular hexagon, well, what I have to do now is find the sum of the interiors and then divide by the number of sides. So the sum of the interior angles is n minus 2 times 180. We're going to divide by n. I know what n is. N is equal to 6 in a hexagon, so it's going to be 6 minus 2 times 180 divided by 6. That'll give me 4 times 180 divided by 6. So each interior angle, if I was to multiply that, it's 720 divided by 6. This is equal to 120. I want you to consider for a moment the picture. Like, let's picture what this looks like. I have a hexagon, so it has 6 sides. Once I knew the exterior angle here was 60, I didn't even have to do all this work that I just made us do. Instead, I should be able to look at this and realize these two angles are a linear pair, right? They have to add up to 180 because they form a straight line when you put them together. They're adjacent angles. So therefore, the angle on the inside has to be 120 degrees. And that just makes it a lot easier for whenever you want to find an interior angle of a regular 30gon. I don't do all of this. Like, that is a lot more work than finding the exterior angle and then using it to find its linear pair, which will be the interior angle. So anytime you have a problem like this, where you're finding one interior angle, here are my steps that I say follow. Find the exterior angle. Find the exterior angle first, or each exterior angle first. How would I do that? It's always 360 divided by the number of sides that the shape has. So 360 divided by 30 is 12 degrees. And then use linear pairs. So use linear pairs to find the interior angle. Because, again, if I was to draw this, I'm not going to draw a 30gon. That's crazy. I like to just draw one little piece of it, maybe. Like, it would go here. So right here, I just found the exterior angle by doing 360 divided by the number of sides. It's 12 degrees. How will I get this interior angle? Because that's what the question's asking me. I would do 180 minus 12, and I get my answer, which is 168 degrees. And that is each interior angle. If you want to plug in 30 to the previous formula, that's fine. But these next two examples are going to show you that I think it makes it a little bit easier to just always deal with exterior angles. Okay, here we know if an exterior angle of a regular polygon measures 15 degrees, how many sides does it have? So we're working backwards here. We're going to take our formula, 360 divided by n, and we know what each exterior angle is equal to. It is equal to 15 degrees. Okay, so I could put this over 1, and now I can cross multiply. I would get 15n equals 360. Divide both sides by 15, and we get our number of sides. I would get n is equal to 24 sides. If it asked me what kind of polygon is it, I would call this a 24gon. They asked me how many sides it has, so I said 24 sides. Okay, so here, if the measure of an interior angle of a regular polygon is 162, how many sides does it have? We could do the same thing here. We could take each individual, the sum of the inside angles divided by n, and then equal it to one individual interior angle. Again, we can only do this when they're regular polygons. I could put this over 162, put this over 1, and cross multiply and do it that way. Or heed my advice, take my advice, and let's do this instead. Let's find each exterior angle. So let me actually, find each exterior angle. The fact that they're linear pairs makes this so much easier. I don't know how many sides it has, so if I draw my polygon, I'm just going to focus on this one angle. It says the interior is 162, which means the exterior angle is 18. So just like the problem before, I'm going to do 360 divided by n. I don't know how many sides it has, but I know the angle is equal to 18 degrees. Cross multiply, 18n equals 360, divide both sides by 18, and we'll get the number of sides is equal to 20 sides. if I did it the long way, this would be n minus 2 times 180 equals 162n. I would have to distribute here. 180n minus 360 equals 162n. Subtract 180n from both sides. Notice what I get. Negative 360 equals negative 18n, and I'm still dividing 360 by 18. They're both negative, so it is going to be positive, and it equals 20. So either way you want to do it is totally fine. I'm always going to find the exterior angle just because it's less work, less places where I could make a mistake. So I will always do it that way. All right, we're going to practice more of these next time I see you in class. But for now, thank you so much for watching. Have a great day. Bye.